Okay, is it the screen is visible to all? Is it the screen is visible to all? Hello.
Yes, sir, visible.
Okay. In the previous lecture, okay, yesterday, we seen that the types of matrices, nilpotent matrix, involutory matrix, and idempotent matrix. Okay. So this is the definition of nilpotent matrix. A square matrix A is said to be nilpotent matrix if there exists a natural number m such that a raised to m is equal to 0. Okay. And we seen that some properties of nilpotent matrix. Now, the next type is orthogonal matrix. Okay, look at it. The next definition, the next type of matrix is orthogonal matrix. What is orthogonal matrix? Look at the definition. A square matrix. Okay, a square matrix A. Okay, the square matrix A is is said to be orthogonal. Okay, orthogonal matrix. Okay, if A into A transpose, okay, is equal to A transpose into A is equal to I. Okay, what is the transpose of a matrix? Interchange row to the column and column to the row. Okay, if suppose A is the matrix such that 0, 2, 3, 4. Okay, so this implies what is this transpose of A? First row is what is A transpose? Okay, this is the first column. Make it to the first row. 0, 3, and second column to the second row. This is 2, 4. Okay, so this is the transpose of a matrix A. If A is the this one. Okay. So what is the orthogonal matrix? A square matrix A is said to be orthogonal if A into A transpose is equal to A transpose into A is equal to I. What is I? Identity matrix. Okay, any doubt in the definition? Okay, so one more definition is there. Okay, okay, look at another definition of orthogonal matrix. A square matrix, a square matrix A is equal to Aij with order n cross n is an orthogonal is an orthogonal matrix. Okay, if and only if first one the sum of square of elements, okay, in each row or column, okay, you can take anyone, row or column of the matrix A is 1. Okay, what is the first condition? The sum of square of each element, okay, of elements in each row or you can take column of A is equal to 1. And the second one is the sum of product of, okay, elements in any two rows or column. Any two rows or column of an matrix A is 0. Okay, if these two conditions satisfies, then the matrix A is called as orthogonal matrix. Then we can say that A is the orthogonal matrix. For example, look at it. Okay, एक तरी ही definition use करा. A square matrix A is said to be orthogonal matrix if A into A transpose is equal to A transpose into A is equal to I, or we can use this definition. A square matrix A is said to be orthogonal if and only if the sum of square of elements in each row or column of A is equal to 1, or the sum of product of elements in any two rows or columns of A is equal to 0. Okay, for example, look at here. If A is the matrix with order 2, okay, A is the square matrix, order 2, the first row is cos theta and sin theta. Okay, first element is cos theta, second element is sin theta in the first row. And the second row is minus sin theta and cos theta. Okay, where theta belongs to any real number. Okay, now check whether this A is orthogonal or not. What is the first condition? Sum of, square of, element in each row. Okay, take this first row. First row. What is the first element? Cos theta. Sum of, square of cos square theta. Okay, this is the square of this one, and sum of sin square theta. Okay, is equal to what? But sin square plus cos square is, what is the value of this one? Statistics student. What is the value of this one? Sin square plus cos square is equal to 1. And the second one is sum of product of element in any two rows. Okay, what is the sum of? Okay, product of any two row. Take this one is first row and second row, and do the multiply of this one, minus cos theta into sin theta. Okay, product of this two one plus product of this two one, so cos theta sin theta. Okay, this one is plus sign, this one is minus sign, so value of this one is 0. Hence the matrix A is what? Orthogonal. Okay, we can check like this. Okay, or we can check by using the definition A into A transpose is equal to I. Okay, what is the first row is cos theta and sin theta. This one is minus sin theta and this one is cos theta. Okay, now what is the A transpose? सांगा कोणीतरी. फर्स्ट रो काय येईल?
cos theta.
Cos theta and
minus sin theta.
minus sin theta. समजते ना काय चालू आहे? तर मी एकटाच बडबड करत असेल इथे. Okay, so first row is cos theta minus sin theta, and second row is sin theta and
Cos theta.
Okay, now what is the product of A into A transpose? A into A transpose is equal to first A, write down cos theta into and sin theta, this one minus sin theta cos theta. Okay, this is the matrix A, and A transpose is cos theta minus sin theta and sin theta, this one is cos theta. Okay, now do the product of these two matrices. First row with first column. Okay, first element cos theta into cos theta is cos square theta. Okay, plus sin theta into sin theta is sin square theta. Okay, so this is the first entry of product of these two. Okay, and now cos theta into second row, now second column, cos theta into minus sin theta is minus sin theta cos theta, and sin theta into cos theta plus. Okay, this one is sin theta into cos theta. Okay, now second row with first column, minus sin theta cos theta, minus sin theta cos theta plus. Okay, cos theta into sin theta, cos theta into sin theta. Now, second row with second column. Minus minus get plus. This one is the sine square theta plus cos into cos is cos square theta. Okay. Now look at this. This one is minus sign. This one is plus sign. So this is cancelled. Similarly here. Okay. Now cos square plus sine square is 1. This one is 0. This one is 0. And this one is cos square plus sine square is equal to 1. So here A into A transpose is equal to what? Identity matrix of order 2. Okay. Similarly, we can check that A transpose into A is equal to I. Hence, A is what? Orthogonal matrix. Any doubt up to here? Okay, so A is what? Orthogonal matrix. Okay, any doubt up to here?
No, sir.
Okay, now the second example. Now the second example, take the matrix B of order 3 cross 3 cos theta 0 sin theta. Okay, 0 1 0, and third row is minus sin theta 0 and cos theta, where theta belongs to set of real number. Okay, you can check at home. This B is orthogonal. Okay, find out the B transpose and we get B into B transpose is equal to identity matrix of order 3. Okay. So example number third. If C is equal to the matrix with order 4 cross 4. Okay, first row is cos theta 0 0 sin theta. Okay, 0 cos theta. Okay, or cos beta. Change the angle. Cos beta sin beta and 0. And third row is 0 minus sin beta cos beta and 0. And fourth row is minus sin theta 0 0 cos theta. Okay, with order 4 cross 4, 4 cross 4. Okay, and the theta and beta belongs to set of real number. Okay, these are the 4 examples of orthogonal matrix or matrices. Any doubt?
No, sir.
Okay. Now the next is notes are there some. Okay, what are the notes? Okay. Note number 1. If capital A is the matrix and capital B is one another matrix are orthogonal. Okay, orthogonal matrices, then A into B, okay, product of these two matrices, and B into A are also orthogonal matrices. Sorry, orthogonal matrices. Okay, this is the note number 1. Now, second one. For you, there is no need to do again the proof of this one. Okay, ह्याची proof तुम्हाला काही गरज नाही आहे. Now the second note is if A is orthogonal matrix, A is orthogonal matrix, then n belongs to n. Okay, n be the any natural number. The matrix, the power of A raised to n is also orthogonal. Okay, so this is the note number 2nd. Okay, any doubt up to here? Okay, now the next type of matrix is unitary matrix. unitary matrices. Okay, before going to this point, now tell me if the complex number a plus ib. Okay, so this is the complex number now. So tell me what is the complex conjugate of a plus ib. Okay, complex conjugate means what? Conjugate means x bar. We denote the complex conjugate by x bar. Okay, what is the x bar? What is the complex conjugate of this one? If x is equal to a plus ib. सांगा नाव ऐकू देत का आता? स्वाती वाघमारे आहेत का?
येस सर आहे.
काय येईल कॉम्प्लेक्स कॉन्जुगेट? मोहोळकर आहेत का?
येस सर.
व्हॉट इज द कॉम्प्लेक्स कॉन्जुगेट ऑफ ए प्लस आय बी? भूमकर
ए मायनस आय बी.
व्हेरी गुड. मग सांगा ना, बोला ना. ओके,
सॉरी.
ए मायनस आय बी. ओके, सो दिस इज द कॉम्प्लेक्स कॉन्जुगेट ऑफ एनी कॉम्प्लेक्स नंबर. ओके, सपोज तुमचा हा कॉम्प्लेक्स नंबर असेल तर कॉन्जुगेट काय येईल? ए प्लस आय बी, वेर हा रिअल पार्ट असेल, हा इमॅजिनरी पार्ट असेल. ओके, इफ x is equal to 2, okay, we can write this 2 plus 0 आहे. Okay, purely real number आहे. Okay, the imaginary part is 0. Okay, what is x bar? 2 minus 0. ओके, म्हणजेच एखादा नंबर जर रिअल नंबर असेल तर त्याचा कॉम्प्लेक्स कॉन्जुगेट पण काय येतोय? रिअलच येतोय. ओके, सो इफ a is real number, then its conjugate also same, conjugate itself. ओके, सांगण्याचा उद्देश काय? जर ए हा तुमचा रिअल नंबर असेल तर त्याचा कॉन्जुगेट काय येईल? इटसेल्फ. ओके, इफ x is equal to a, then x bar is equal to again a. Okay, if x is equal to a plus ib, then x bar is equal to a minus ib. Okay, concept clear झाला इथला? Okay, now look at the definition of unitary matrices. A square matrix, a square matrix, capital A, okay, is said to be unitary. Okay, unitary matrix if a into a theta is equal to a theta into a is equal to I. Okay, orthogonal ला काय होता? A into A transpose. Okay, look at here the definition of A into A transpose for orthogonal. But what is the unitary? A into A theta is equal to A theta into A is equal to I. What is the A theta? A theta is conjugate transpose of the matrix A. For example, look at here. If A is equal to, this one is the matrix 2 by 2, 2 plus 3i, 3 plus 4i, and this one is like 6 plus I and 7 plus 8i. Okay, so suppose this is the matrix A with entries in the complex number. A theta is nothing but what? Complex conjugate transpose of A. याचा ट्रान्सपोज करा आधी. ओके, ट्रान्सपोज करून काय करायचं आहे? कॉन्जुगेट पण घ्यायचं. कॉन्जुगेट ट्रान्सपोज ऑफ ए. ओके, याचा आधी या प्रत्येक एलिमेंटचा काय घ्या? कॉन्जुगेट घ्या. त्याचा काय करायचं आहे? ट्रान्सपोज. ओके, सो दिस इम्प्लाइज ए थीटा इज इक्वल टू ए बार ऑफ टी. ओके, transpose of complex conjugate of A. Okay, which is equal to, this implies, okay, if A is this one, the matrix. What is the conjugate of this one? तुम्हाला फर्स्ट रोला काय करायचंय, फर्स्ट कॉलम करायचंय ट्रान्सपोज म्हटल्यानंतर. ओके, 2 + 3 यायला काय करणार, फर्स्ट एंट्री विथ कॉम्प्लेक्स कॉन्जुगेट काय येईल, 2 - 3 आहे. 3 + 4 आयचं काय होईल, 3 -
-4.
ओके काय,
6 minus I. 7
नाउ
minus
सेकंड रो विथ interchange with second column. So this is the 6 - I and 7 - 8I. And this matrix is nothing but A theta. Okay, and what is the unitary matrix? If it satisfies this property, A into A theta is equal to I, is equal to A theta into A. Okay, करते conjugate of transpose of A or transpose of conjugate of A. ट्रान्सपोज करा किंवा आधी करून कॉन्जुगेट करा किंवा कॉन्जुगेट करून त्याचा ट्रान्सपोज करा. ओके, समजा ए हा रिअल नंबर असेल, ए हा रिअल असतील, सगळे एंट्रीज हे रिअल नंबर असतील, नॉट कॉम्प्लेक्स. कॉम्प्लेक्स तर आहेतच, पण प्युअरली रिअल नंबर असेल, 2, 3, 6 and 7. ओके, आता तुमचा इथे इमॅजिनरी पार्टच नाहीये. ओके, what is the A theta? A theta is nothing but complex conjugate of a transpose of complex conjugate, which is equal to real numberचा conjugate काय येईल,
2,
तोच
6.
येईल 2. ट्रान्सपोज केल्यानंतर हा 3 कुठे येईल, खाली येईल. ओके, and this one is 6 and 7. Okay, if all the entries, okay, are real number. Okay, if all the entries are real number, then we have complex conjugate, transpose of complex conjugate is equal to transpose of A. ओके, हा म्हणजेच काय तुमचा A ट्रान्सपोज आहे ना, म्हणजे इथं बारचा काही उपयोगच नाही होणार, तुमचा कॉम्प्लेक्स कॉन्जुगेटचा काही उपयोगच नाही होणार, बिकॉज ऑल द एंट्रीज आर रियल. एनी डाऊट?
No, sir.
ओके, समजते काय चालू आहे?
हो सर.
Okay, so this is the definition of unitary matrix. A square matrix A is said to be unitary matrix if A into A theta is equal to A theta is into A is equal to I, where A theta is what? Conjugate transpose of A, or we can say that transpose of conjugate of A. Okay, wait a minute. Wait a minute. Okay. What is A theta? A theta is nothing but transpose of, write down this one, transpose of conjugate of matrix A. Okay, so this is the definition of unitary matrix. Now look at the example. Example number 1. If A is given by 2 by 2 matrix like this, cos theta, I sin theta, I sin theta, and this one is cos theta. Okay, now what is the value of A theta? आता IB असेल, याचा कॉम्प्लेक्स कॉन्जुगेट काय असेल, इफ x इज इक्वल टू IB, then x bar इज इक्वल टू मायनस IB. इथं प्लसचा काय होणार, इमॅजिनरी पार्टचा जो साइन काय होणार, चेंज होणार. ओके, व्हॉट इज द इमॅजिनरी पार्ट इज I sin theta. Okay, now A theta is equal to conjugate of cos theta. Okay, आणि हा जो
Cos
आहे
theta
फर्स्ट रो
minus I sin theta.
minus I sin theta. Okay, now this one is again minus I sine theta.
Sin theta.
And this one is a real number. That's why we have taken as it is, sine theta. Now do the product of a into a theta. A into a theta is equal to cos theta in I sine theta, I sine theta, and cos theta into cos theta minus I sine theta minus I sine theta, and this one is cos theta. Okay. First row with first column. Cos theta into cos theta is cos square theta. I theta into sine theta into sine theta is plus sine square theta, and I into I is I square. Okay, and this one is minus sign as it is. But what is the value of minus I square? What is the value of this one? I square. I square ची value काय असते?
Plus I.
-1 ना. I square -1 असतो. Okay, I ची value काय असते? Square root of -1. Okay, so here we get this one is -1, minus minus we get +1. Okay, so here +1. That is cos square theta plus sin square theta. This is the first entry. Now the first row with second column. Now this is the minus I sin theta cos theta. Okay, this one into this one. And now I sin theta cos theta plus I sin theta cos theta. Any doubt?
No, sir.
Okay, now second row with first column. Sin theta into cos theta with positive I. I sin theta cos theta. Okay, first row with second column. Sorry, I sin theta cos theta. Okay, plus this one is minus I. Okay, with minus I sin theta. Okay, and this one is cos theta. And second row with second column now. I into minus I. This one is minus I, this one is I. So this is minus I square, but I square is -1, so minus minus get 1 here plus with sine square theta. Okay, so this one is sine square theta. And cos theta into cos theta is plus cos square theta. Okay, this one is minus, this plus minus get cancelled. So here cos square plus sin square is equal to 1, 0, 0, 1. Okay, so this is the A into A theta. Any doubt? Which is equal to identity matrix of order 2 cross 2. Hence, the given matrix A is what? Unitary matrix. Any doubt up to here? Okay, now after that we are going to some notes are there. Okay, what are the notes? Okay. First one, or remarks are there. If A and B are unitary matrices, if capital A and capital B are unitary matrices, okay, if or matrix of matrices, okay, then A into B and B into A, the product of these two matrices, okay, A into B or B into A, are also unitary matrices. Okay, second, if A is unitary matrices, if capital A is unitary matrices, okay, then the any power of A, okay, that is A raised to n, where n belongs to natural number, is also unitary matrix. Matrix, okay, एकच matrix है ना, matrix. is matrix. Okay, now the third one, every. Okay, important is this one. Every real orthogonal matrix is unitary matrix. Okay, these are the three notes of there. Okay, what is the meaning of last one? Real orthogonal, real orthogonal matrix. Okay, every real orthogonal matrix is unitary matrix. Okay, if A is the orthogonal matrix with real entries. ओके आता काय पाहिलं आपण जर रिअल असेल तर त्याचं काय तो ए थिटा इज इक्वल टू ए ट्रान्सपोज. ओके, एखाद्या मॅट्रिक्स मध्ये जर सगळेच रिअल नंबर असतील आणि तो ऑर्थोगोनल असेल तर तो काय असतो? युनिटरी मॅट्रिक्स. एनी डाऊट अप टू हियर?
हो सर.
Okay. Now the next type of matrices is symmetric matrix and skew symmetry. The next type is symmetric matrices. Symmetric and skew symmetry. Matrices. Okay, now first we see the definition of symmetric matrix. A square matrix. A square matrix A is equal to Aij with n cross n. Okay, of order n cross n is said to be symmetric if A is equal to A transpose. Okay, A is equal to A transpose. For example, if A is the matrix with order 1, -2, -2, 3. Suppose this one is the matrix A. What is the A transpose? Make the first row to the first column. 1, -2. Second row with second column. -2, 3. But both are equal, A and A transpose. This implies A is symmetric matrix. Okay, any doubt in the definition of symmetric matrix?
No sir.
Okay, another one, take another one example. 3 by 3 here. 1, 2, 3. 2, 4, 5. Okay. 3, 5, 6. Okay, what is the B transpose? This implies B transpose equal to, make first row to the first column. 1, 2, 3. Okay, 2, 4, 5. Second row to second column, and third row to the third column. 3, 5, 6. Okay, this implies B is equal to B transpose. This implies B is symmetric. Okay, so this is the definition of symmetric matrices and the examples. Now, what is the skew symmetric matrix? The definition of skew symmetric matrix. A square matrix A is equal to Aij. Okay, with entries with Aij of order n cross n. Square matrix म्हटल्यानंतर काही n cross n order. Okay, it's said to be skew symmetric symmetric matrices or symmetric matrix if A is equal to minus A transpose. Okay, a skew matrix, a square matrix A is said to be skew symmetric matrix if A is equal to minus A transpose. Okay, for example, if A is equal to 0, 2, minus 2, 0. Okay, what is the A transpose? This implies A transpose is what?
0 minus 2,
0.
0.
A transpose म्हटलं मी. 0,
हाँ
2 and minus 2, 0. This
कॉलम में
minus A transpose is what? Multiply minus sign to the all the elements of this matrix. So 0, minus minus get plus 2. Okay, this one is minus 2 and this one is 0. Okay, so this implies A is equal to बघा हा मॅट्रिक्स आणि हा मॅट्रिक्स सेम दिसते minus A transpose. This implies A is skew symmetric matrix. Okay, now take one another example. B is equal to 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0. Okay, this implies what is the B transpose? 0, 1, 2. Make it first row to the first column, second row with second column, minus 1, 0, 3.
माइनस
Okay, and minus 2, minus 3, 0.
सर
This
माइनस
कुठे
सेकंड कॉलम में सेकंड कॉलम में
सेकंड रोला आपण सेकंड कॉलम केलंय, थर्ड रोला आपण थर्ड कॉलम केलंय. ओके,
यस यस
now this implies minus B transpose is equal to, okay, multiply minus 1 with all the elements of this one. 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0. Okay, which is equal to B. Okay, so this implies B is equal to minus B transpose. Okay, so this implies B is what? Skew symmetric matrix. Okay, एक ऑब्झर्व केलं का तुम्ही? स्क्यू सिमेट्रिक मॅट्रिक्स असेल, ऑल दी डायगोनल एलिमेंट्स मस्ट बी 0. ओके, एखादं मॅट्रिक्सचं स्क्यू सिमेट्रिक असेल तर त्याच्या ऑल डायगोनल एलिमेंट्स काय असायला हवेत? 0च असायला हवेत. ओके, अदर देन 0 पॉसिबल नाहीये. जर एखाद्या डायगोनल मॅट्रिक्सच्या डायगोनल एलिमेंटला जर नॉन 0 एलिमेंट असेल तर तो स्क्यू सिमेट्रिक कधीच होऊ शकत नाही. प्रत्येका डायगोनल एलिमेंट म्हणजे कोणते? हे डायगोनल एलिमेंट. ओके, हा डायगोनल एलिमेंट. ओके, इथे काय येईल तुमचं डायगोनल एलिमेंट्स? These are the diagonal elements. Okay, if the matrix is skew symmetric, then all the diagonal elements must be 0. Okay, it is not possible the matrix is skew symmetric with non-zero diagonal elements. Okay, understood?
यस
Yes.
Okay, so these are the examples of matrix symmetric and skew symmetric matrix. Okay, some properties are there, notes or remarks. What are the notes? If A and B are symmetric matrices, okay, then Symmetric matrices of same order. दोघांची ऑर्डर कशी अशी व्हायला कशी असायला हवी? सेम ऑर्डर with same order and small k is any number. कोणताही नंबर आहे तो. Okay. Then look at here. First one. K into that matrix A is also symmetric. Okay, second one. A plus B is also symmetric. Okay, K into A is symmetric. It means what? K into A transpose is equal to K into A transpose, which is equal to K as it is. A transpose म्हणजे काय तुमचा asymmetric असल्यामुळे काय येईल? A transpose हा A येईल. Okay, so this implies K A transpose is equal to K. Okay, this implies A plus B हा जो काही मॅट्रिक्स आहे तोही कसा असेल? सिमेट्रिक. म्हणजे काय? A plus B transpose is equal to A transpose plus B transpose, but A transpose is A, B transpose is B. Okay, so A plus B transpose, bracket transpose is equal to A plus B. Okay, so A plus B is also symmetric. Third one. Okay, if K1, K2 up to so on Kn, okay, are any numbers, कोणतेही numbers असतील, and A1, A2 up to so on An are symmetric matrices, it implies K1 into A1 plus K2 into A2 plus up to so on Kn into An also symmetric. Okay, fourth property. A raised to n, where n belongs to natural number, is symmetric. Okay, if A is symmetric असेल तर any power of A, okay, is also symmetric matrix. Okay, so these are the some properties of symmetric matrices. Okay, now some remarks are there. Note down that remark. फास्ट चाललंय का खूप? फास्ट होत असेल तर सांगा.
No, sir.
Okay, now the remark number 1. If A is any matrix, okay, if A is any matrix, then A into A transpose and A transpose into A are always symmetric. What is the meaning of this one? If A is the any matrix, घ्या कोणताही matrix. For example, 1, 2, 3, 4 हा तुमचा 2 by 2 चा matrix आहे. Now what is A transpose? 1, 2, 3, 4. Okay. Now do the product of A into A transpose. A into A transpose is equal to 1, 2, 3, 4. Okay, into 1, 2, 3, 4, which is equal to 1 first row with first column. 1 into 1, 1 plus 2 into 2 is 4. Okay, now first row with second column. 1 into 3 is 3. 2 into 4 is 8. Okay, now second row with first column. 3 into 1, 3. 4 into 2, 8. Now second row with second column. 3 into 3, 9. 4 into 4, 16, which is equal to, this one is 5, 8, 8, 16 plus 9, 24. Okay, now this is the product of what? A into A transpose. Now we have taken here A is the any matrix, then A into A transpose. This is the symmetric matrix.
511 sir.
Today, sorry, हाँ, thank you. Okay, ना? 5, 11, 11, 21, sorry. Now, so this is the symmetric matrix. Okay. हा तुमचा काय झाला सिमेट्रिक मॅट्रिक्स. कसा सिमेट्रिक झालाय पहा. टेक दिस मॅट्रिक्स इज बी इज इक्वल टू ए इंटू ए ट्रान्सपोज. व्हॉट इज द मॅट्रिक्स 5, 11, 11, 24. हां सिमेट्रिकची डेफिनेशन काय बी इज इक्वल टू काय असायला हवा तो बी ट्रान्सपोज. आहे का बी ट्रान्सपोज. फाइंड out the B transpose. First row with first column 5, 11. Okay, and now this is the 11, 24. This implies B is equal to B transpose. But what is B? So this implies B is symmetric matrix. Okay, but what is B? A into A transpose is symmetric. Okay, any doubt?
No, sir.
Okay, if you take any A matrix A, कोणताही matrix घ्या तुम्ही, A into A transpose always symmetric यायला हवा आणि येतोच तो. Okay, now the second remark, if A is any square matrix, okay, if A is any square matrix, then A plus A transpose also symmetric. Also म्हणण्यापेक्षा always symmetric. A in plus A transpose always symmetric. Okay, take the similar example. काय होता तुमचा A 1, 2, 3, 4. Okay, what is A transpose 1, 2, 3, 4. What is A plus A transpose? Okay, give it name as a B. 1, 2, 3, 4 plus 1, 2, 3, 4, which is equal to 1 plus 1, 2, 2 plus 3, 5, 2 plus 3, 5, 4 plus 4 is 8. Okay, so this one is B. Okay, now what is the B transpose? 2, 5, 5, 8. So this implies B is equal to B transpose. Okay, this implies B is symmetric. Okay, so this implies what is B? A plus A transpose is symmetric. Any doubt?
No, sir.
Okay. The note number 3rd. If A is any square matrix, okay, A is any square matrix, then A minus A transpose is always, anybody knows what is A minus A? A transpose is always, माहित आहे कोणाला? A plus A transpose हा सिमेट्रिक असेल तर A minus A transpose काय असेल?
Skew symmetric.
Skew symmetric. Okay. Symmetric. Okay, now look at this one. तोच एक्झाम्पल घेतो आपण पुन्हा. A is equal to काय होता 1, 2, 3, 4. Okay, and A transpose. What is A transpose? 1, 2, 3, 4. This implies A minus A transpose. Say this one is the B matrix. Okay, 1, 2, 3, 4 minus 1, 2, 3, 4. Okay, which is equal to 1 minus 1 is 0. 2 minus 3 is minus 1. 3 minus 2 is 1. 4 minus 4 is 0. Okay, so this is B is equal to 0 minus 1, 1, 0. Okay, so this implies what is B transpose? 0, minus 1, 1, 0. So this implies minus B transpose. Okay, multiply with minus 1 to the all the elements. 0, minus 1, minus minus, this was plus 1, and this one is 0. But what is this one? B, matrix B. So this implies B is equal to what? Minus B transpose. Okay, so this implies B is skew symmetric. Okay, what is B? A minus A transpose is skew symmetric. Any doubt? Any doubt up to here?
No,
No,
sir.
sir.
स्पीड होते का खूप काही सोपं आहे ते अवघड नाही आहे इतकं.
No, sir.
Okay, wait a minute. Okay. Now the next and last remark, the only matrix of any order which is both symmetric and which as well as symmetric as well as skew symmetric. Okay, as well as skew symmetric. असा कोणता मॅट्रिक्स आहे जो सिमेट्रिकही असायला हवा आणि स्क्यू सिमेट्रिकही असायला हवा? इज द ओनली, तो एकच आहे फक्त, कोण? नल मॅट्रिक्स ऑफ दॅट ऑर्डर. ओके, म्हणजे काय? नल मॅट्रिक्स हा असा मॅट्रिक्स आहे, ओके, सपोज 0 0 0 0. This is the only matrix such that the matrix A is also symmetric as well as skew symmetric. Okay, MCQ ला वगैरे काही वेळेला विचारू शकतो. Okay, any doubt up to here?
No, sir.
Okay, wait a minute. Okay, okay, now for today it is sufficient now. Okay, so two more types are there: Hermitian matrix and skew Hermitian matrices. Okay, the remaining part we will the sir will take. Okay, sir will take from Monday. Okay, for today it is sufficient now.